Okay, grade 8. We are doing chapter 1, lesson 3. Right there. So this is lesson 3 in chapter 1. It says multiply and divide monomials. The vocabulary that you need to know is all vocabulary from before to now to include monomial. Okay? Alright. So make sure you write your heading. Today's date is September 14, 2020. So the first thing we need to define or we need to understand is what is a monomial. Okay? A monomial is a number. So that means it can be a fraction, a decimal, whole, or integer. Okay? It is also a variable. Okay? It can be a variable. So that means you can use any letter to represent a value. That's what a variable is. It is a product of a number and one or more variables. Okay? So you can write 3x to the 4th power or 3 squared x to the 4th power m to the 9th power like this. So you can either use one variable or you can use two variables. Okay? Now, so we need to understand some laws of exponents in this lesson that will help us solve whatever questions we will encounter or whatever questions we will be given under this chapter, under this lesson, okay? And more. So the first thing you need to understand is that when your base is a positive, whether it is a letter, whether it is a number, a whole number, whether it is a fraction or a decimal, as long as it is positive and the exponent is 0, then the answer will always be 1. When your base is a negative, whether it is a variable, whether it is a number, and the exponent is 0, then your answer will always be a negative. Your answer will always be -1. 0 goes with 1. So you need to look whether it is -1 or +1. If your base is in the bracket and it is a negative and it is raised to the 0th power, then it will always be +1. Always. Okay? Right. So the thing you need to know, when there is no bracket, it is negative. When there is a bracket, it is positive, as long as the exponent is 0. Please don't say this about any other exponent. I'm only talking about when the exponent is 0. Okay? When we have the exponent 1, we never write it. You just write the base the way it is. Okay? So, a to the 1st power is just a. Whether it is a fraction, a decimal, or sorry about that. Okay. Whether it is a variable or a whole number or a fraction or a decimal, okay? So if I write here 5/10 to the 1st power, the answer is just 5/10, like that, okay? All right. When your base is negative and your power is 1, you just write your base the way it is. It doesn't matter whether it's a fraction, a decimal, a number, or a variable. The same thing here. Our base is in a bracket and it is -a. You just repeat the bracket and then value inside, okay? So remember, if you don't see the exponent is 1, okay? So now, let us move to the product of powers. When you see the word product, it means multiplying. So in this lesson, we are learning how to multiply powers. Now, when you're being given powers, some powers will have the same bases. Some powers, the bases will be different. We need to know how to work with them in either scenario, okay? So when the bases are the same, add the exponents. And you must check, okay? Everything in math, we must confirm that our answer and our steps are correct. So here, our bases are the same because this is 6 and this is 6. Even though our exponents are not the same, I am looking at the bases, not the exponents. First, confirm the bases are the same. If the bases are the same, then add the exponents. So that's what we did over here. And our answer is 6 to the 7th power. And then you can do this. You can do 6 to the 7th power. You press this box over here, the X with the box, and you type your exponent, and you press your equal sign, and you get your answer right there, okay? Now, to do the check, you write it out the long way. 6 to the 3rd power means 6 times 6 times 6. 3 of them, because your exponent is 3. 6 to the 4th power means 6 times 6 times 6 times 6, 4 of them, okay? Now, you need to confirm how many 6s you have. You start counting. 1, 2, 3, 4, 5, 6, 7 is your last count, and that becomes your exponent. And then 6 to the 7th power is 279,936. Make sure you put your commas, okay? All right, let us do this one. Here now you see we have 3 bases. All our bases are the same. I also notice this base does not have an exponent, so I know the exponent is 1. And since all my bases are the same, then I will add my exponents. So 3 to the 3rd power plus 0 plus 1. So all my exponents I added over there, right? 3 plus 0 is 3, plus 1 is 4. 3 to the 4th power is 81. Now you do your check. 3 to the 3rd power, that means write 3 3s and multiply them. 3 to the 0th power is 1. 3, what is this? And 3 to the 1st power is only 1 3. So then I don't have to write this 1 because a number multiplied by 1 is the same number. So I count how many 3s I have. 1, 2, 3, 4. So I wrote them out there. My last count was 4. That is my exponent, which is equal to 81. Okay. Now, let us do when the bases are variables or letters. You see my bases are the same because they are both e's. So what do I need to do? E to the 3rd power plus, because we are multiplying. It is plus because we are multiplying. -4. Now remember what we said in grade 7? When we have 2 signs next to each other, we need to convert them to one sign. If my signs are different, then they become minus or they become negative. So then you will do 3 subtract 4, which is -1, and this is your answer, okay? And how did I know it is -1? I drew 3 positives and 4 negatives, and then I made my 0 pairs. A positive and a negative together makes a 0 pairs. I used everything, so what is remaining is only 1 negative, and I wrote it over there. Now let us look at question 4. You're going to notice question 4 has a coefficient and it has powers, okay? Now, here you will put your friends together, your like terms together. So you'll open a bracket for coefficients and you'll open your bracket for the variables, okay? The coefficients, they don't have to be the same. You just do what it says. -3 times 4 is negative 12. Then you look at your bases. If your bases are the same, you add them. So x to the second power plus 5, the exponent becomes 7. And there is your answer, negative 12, x to the 7th power. All right, let us look when the bases are different. When the bases are different, do not add the exponents. That is not the rule. You must solve it the way we have done before in lesson 2. So you just do 5 to the second power plus 4 to the second power. Times 4 to the second power. 5 to the second power becomes 5 times 5. 4 to the second power becomes 4 times 4. 5 times 5 is 25 times, because of this, and then 4 times 4 is 16. When you multiply, you should get 400. Okay? All right, we look at this. We see our bases are not the same because we have different variables. This is D and this is E, so there is nothing I can do. So I just expanded them, and then I wrote them back without the multiplication. So this step means this step means this step, okay? When you write out all your steps, you can look at the choices you have on Aleph and confirm which one matches. That is why you have to write your steps down. When you write your steps down, this is helping me to see where you're going wrong, or to show me that you're understanding. That is the reason why you have to write steps. The steps help you with the thinking. It helps you to see where you went wrong. Checking is easy, okay? All right, let us look at this. We have the same coefficient, but we have different bases, okay? And since our coefficients are the same, so we will put all our coefficients in the bracket, its own bracket. Then we will put all our powers in their own bracket. All right, so then negative 3 times negative 3 times negative 3 becomes negative 27. How did I know? A negative times a negative is a positive, times another negative is a negative. 3 times 3 is 9. 9 times 3 is 27. When I look at my powers, I arrange them I arrange them in alphabetical order, and then I look if the bases are the same. None of the bases are the same, then I just write them without the dot, and that is our answer. Okay? So remember, these values we are calling coefficient. The value that is in front of your variable, okay, we are calling coefficient. The same here. These are coefficients. Okay. All right. Now, let us do quotient of powers. Quotient of powers means dividing of powers. Okay, when you see the word quotient, you know you're going to divide. We saw this in grade 7. Okay, this vocabulary we saw in grade 7, in grade 6, in grade 5. Okay, when bases, even here we're going to divide it into two parts. When the bases are the same and when the bases are different. So let's do this part where the bases are the same. When the bases are the same, you subtract the exponents. Okay. Now, how do you know you're dividing? Because it looks like a fraction, okay? When you see the fraction, you know you're dividing. So the next thing you're checking whether the bases are the same. Yes, the bases are the same, then you just write the base here. And then what do you do with the exponents? You subtract. The numerator exponent, you write first. The denominator exponent, you write second, okay? Don't confuse. The exponent on top comes first, the exponent at the bottom comes second. And because you're dividing, you subtract. Okay? 4 minus 3 is 1, so this is 7 to the first power, which is just 7. Okay? Remember I said when the exponent is 1, you don't need to write it. Let us check. So, in our numerator, we have 7 to the 4th power. So that means I'm going to write 7 4 times and multiply. 1, 2, 3, 4. Then I'm going to write 7 to the third power and multiply. So that means 7 3 times and multiply. 7, 7, 7 and multiply. And then, because they are the same, I am going to divide by using the crossing method. I don't have to do long division, the crossing method. So I say this 7 goes into this 7 one time. And I write 1 there and 1 here. This 7 goes into this 7 one time and goes into this 7 one time. Okay, that's what that crossing means. When you cross these 7s, you have to write. When you cross the same number, you write 1. Okay, like that. Now, in our denominator, we all have 1. And we know 1 times 1 times 1 is just 1. So it doesn't matter. We don't need the denominator because it is 1. If it was any other number, you must write it the way it is. It has to be there in the denominator. But because it is 1, you don't need to write it. Okay? And then in our numerator, we have 1 times 1 times 1 times 7. So that is why you have to write all this. And then you do 1 times 1 times 1 is 1 times 7 is just 7. And this confirms this is correct. Okay? If your answer in the check is different, either you did the check wrong or you did this wrong. Okay? All right, n to the 9th power and n to the 4th power, our bases are the same. We are dividing, so we're going to subtract our exponents. I will start with 9, then I will subtract 4. So 9 minus 4 is 5. So my base is n to the 5th power. This is my answer. Let us do the check. So I will write 9 n's. All of this is 9 n's. I will write 4 n's in the denominator, and each n I will cross out with 1 n on top. 1 n at the bottom crosses with 1 n at the top. Okay? So I am left with 1 times 1 times 1 times 1, which is 1. I don't need to write it in the denominator. In the numerator, I am left with 1 times 1 times 1 times 1 times n times n times n times n times n. These n's over here are 5 because I counted. So my last count is 5. That is my exponent. Okay? All right, let us do this one. So here you have your question, and they tell you to simplify. So what I would love to do is I arrange my powers from least to greatest, both in the numerator and in the denominator, because now they're everywhere, okay? So my smallest power, the power with the smallest base is 2 to the 5th power, so I'll start with that. Then I will do the 3, and then I'll do the 4, and then I'll do the 6, okay? And then I find the friend down here. So the one with the same base, 2 to the 5th power, has the same base as 2 to the 4th power, like that, the same thing. 3 to the 4th power, the base is the same. 4 to the 2nd power, the base is the same. 6 to the 3rd power, the base is the same, okay? Now, I have confirmed that each base is the same for each pair. I am going to subtract. So 2, 5 minus 4. 3, 4 minus 4, 4, 7 minus 2, and 6, 8 minus 3. Now 2, 5 minus 4 becomes 1. 3, 4 minus 4 becomes 0. 7 minus 2 becomes 5, and 8 minus 3 becomes 5. So in my box, I have 2 to the 1st power times 4 to the 5th power times 6 to the 5th power. Or I will continue. So 2 to the 1st power becomes 2. 4 to the 5th power becomes 1024. And 6 to the 5th power becomes 7,776. Okay? When I multiply these three values, I got 31,850,496. Okay? So from here, you come here. All right. So let us do this one. I have I have coefficients and I have variables, okay? So I will do my coefficients first. So 24 divide 3, which is 8. My bases are the same, so I will subtract my exponent. So 8 minus 5 becomes 3, and this is my solution to my fourth example, okay? Now, let us see when the bases are different. When the bases are different, do not subtract the exponents. Do not. Okay? You just solve them. 5 to the second power becomes 5 times 5. 10 to the second power becomes 10 times 10. 5 times 5 is 25. 10 times 10 is 100. And because our answer is a fraction, we have to simplify. So our greatest common factor of 25 and 100 is 25. So what do we do with the greatest common factor? We divide the numerator and the denominator by the greatest common factor. 25 divide 25 is 1. 100 divide 25 is 4. So this is our answer in the simplest form. All right. So here, our bases are not the same. So because our bases are not the same, this is your answer. Just leave it as it is. M to the 4th power, n to the 5th power. And then you write, we cannot solve or simplify because the bases are not the same. That is how we answer this question, okay? Don't worry about this line. Okay, so this is your question. You checked if your bases are the same. You realize they are not the same, so you cannot do anything about it, okay? Then you will be given word problems, and you should know which words mean to multiply, which words need to divide as you're reading your question. These are not all the words that mean multiply. That means you need to know and practice how to read math and English. If you practice how to read math correctly and you practice how to read English correctly, then you will know whether you need to multiply or divide, okay? So here are some of the words you will see. If you see the word per in a sentence, think about multiplication. For every, think about multiplication. Product, think about multiplication. When you see the word about how many times longer, or how many times shorter, or how many times thicker, thinner, faster, heavier, okay? Then you know you're going to divide. So you'll always put the big number on top and big value on top and the small value at the denominator, okay? So the big value is in the numerator, the small value is in the denominator, and then you divide. And then the answer you get, you answer using the word the question gave you, okay? Now, looking at these powers, 3 to the 8th power is greater than 3 to the 2nd power. Why? Because 8 is bigger than or is greater than 2. So that's how I knew 3 to the 8th power is a greater value or a bigger value compared to 3 to the 2nd power. Okay? All right. So that is it. Please make sure you do your examples A, B, C, D, E, F, G, H, I. And then I will see you tomorrow, inshallah. Okay?